Look, everybody knows the numbers. 100 billion galaxies, each one packed with 100 billion stars, planets everywhere you look. And you sit back and say, well, obviously somebody else is out there. It would be crazy to think otherwise with all those chances, all those rolls of the dice. Of course, there's someone, probably millions of someones, maybe billions of civilizations, scattered across the sky, chatting away, building things, wondering about us. That is the most natural, most reasonable, most intuitive conclusion a human being can draw. And I believe it is completely wrong. Not because I want it to be wrong, not because I enjoy making people uncomfortable, but because I sat down with a pencil and a piece of paper and actually did the arithmetic. And when you do the arithmetic honestly, when you refuse to let wishful thinking sneak in through the back door, you end up in a very cold, very quiet room, and you're the only one in it. And I've spent a long time thinking about this, and I've talked to biologists, astronomers, chemists, engineers, all kinds of people. And most of them start from the same place. They say, Richard, the numbers are too big. You can't fight the numbers. And I say, yes, I can, because the numbers on the other side of the equation are big too. And nobody wants to look at those. Now let me be clear. I'm not talking about bacteria. I'm not talking about some slime on a rock under the ice of some frozen moon. Maybe that's there. Probably that's there. Frankly, chemistry likes to make complicated molecules, and complicated molecules sometimes start doing interesting things. Fine. I'm talking about something that can look up at the sky and wonder, something that can build a radio telescope, something that can ask the question we're asking right now. That kind of life, intelligence, consciousness, technology, whatever you want to call it. And the reason most people believe it must exist elsewhere is simple. They look at the size of the universe and they can't imagine all of that space being empty. It feels wasteful. It feels wrong. Surely, they say, surely nature wouldn't build all of this for just one audience. Let me take you through the logic, because the logic sounds so good at first. It really does. Start with our own galaxy, the Milky Way. About 200 billion stars. Now we know from the Kepler observations, well, from what astronomers have found, that most stars have planets, not some special fraction. Most, the average star has at least one planet, and many have several. So, in our galaxy alone, you're looking at hundreds of billions of planets. Some estimates go higher, maybe 1 trillion, when you count all the little ones. Of those, a meaningful fraction sit in what people call the habitable zone. Not too close to the star, not too far. The range where liquid water could exist on the surface. Now that range depends on the kind of star and the kind of atmosphere. So, it's fuzzy, but even conservative estimates give you tens of billions of potentially habitable worlds in this one galaxy. And by the way, habitable zone is a terrible name for it. It should be called the liquid water zone, because that's all it really means. It doesn't mean there are nice parks and restaurants. It means the temperature might allow water to be liquid. That's it. Mars is in the habitable zone. Mars is not a nice place to live. Venus, depending on how you count, was close to the habitable zone once. Venus has a surface temperature of about 860 degrees F and rains sulfuric acid. Habitable, sure, but people hear habitable zone and they picture forests and oceans and civilizations sitting around having coffee. That's a long way from temperature permits, liquid water, a very long way. Tens of billions in one galaxy. And there are hundreds of billions of galaxies in the observable universe. So you multiply it out, you get a number so large, it barely means anything. Something like 10 to the 22nd or 10 to the 23rd potentially habitable planets across the observable universe. That's 10,000 billion, give or take. And people look at that number and they say, case closed. There's no way we're alone. The math won't allow it. I understand why they feel that way. If you told me there were 10,000 billion lottery tickets and only one of them was a winner, I'd bet everything I own that someone's holding it, the numbers are just too large. But here's where the trouble starts. Because having a habitable planet is not the same thing as having life. And having life is not the same thing as having intelligence. And having intelligence is not the same thing as having technology. And having technology is not the same thing as having technology. Right now, at the same time, we happen to be looking. Each of those steps is a filter, and we don't know how fine those filters are. That's the part people skip over. They get excited about the big number at the top, and they forget to ask, what do I need to divide it by? There's a famous equation for this. Frank Drake wrote it down in 1961. It's not really an equation in the physics sense. It's more of a way of organizing your ignorance. You start with the rate of star formation. Multiply by the fraction of stars with planets. Multiply by the number of habitable planets per star system. Multiply by the fraction of those where life actually develops. Feroce, multiply by the fraction where life becomes intelligent. Multiply by the fraction that develops communication technology. And finally, multiply by the average lifetime of such a civilization. Beautiful structure, terrible data, because the first three terms we can estimate reasonably well. Stars form at maybe a few per year in our galaxy. Most have planets. Maybe 20% have something in the habitable zone. Fine. But terms 4, 5, and 6, we have absolutely no idea. None. We're guessing. And depending on what you guess, the answer ranges from millions of civilizations in our galaxy to less than one. The equation doesn't tell you the answer. It tells you what you don't know. And what you don't know is almost everything. The last term is especially vicious. The average lifetime of a technological civilization. How long does a species keep its radios on? 1,000 years, 10,000, 1,000,000. If it's short, if civilizations typically burn out in a few centuries, then even if millions have existed, almost none are around at the same time. Ships passing in the night. Except the night is 13 billion years long and the ships are lit for an instant. Let me show you what I mean. Take the first step. Going from a sterile planet with the right conditions to actual life. Simple single-celled life. How hard is that? Well, we know it happened here. It seems to have happened fast. Geologically speaking, within a few 100 million years of Earth cooling down enough to have liquid water, something was alive. That makes some people think it's easy. Chemistry plus water plus energy plus time equals life. Simple recipe. But we only have one example, one. And that one example is biased because if it hadn't happened, we wouldn't be here asking the question. You can't draw a statistical conclusion from a sample of one, especially when the sample is selected by the outcome. That's not science. That's a card trick. For all we know, the origin of life requires such an unlikely chemical accident that it happens on only one planet out of every 10 to the 20th. If that's true, then even with all those habitable worlds, you'd expect life to arise in the observable universe, maybe once, maybe, and we'd be it. I'm not saying that is the number. I'm saying we don't know the number, and that's the crucial point. People pretend they know it's high because it feels like it should be high because life happened quickly here. But feeling is not calculating. Let me give you an analogy. Imagine you're dealt a hand of cards, 5 cards, and they're a royal flush. You might say, wow, that happened on the very first deal. It must be easy to get a royal flush. But you'd be wrong. But probability of a royal flush is about 1 in 650,000. You just happen to get lucky. If you insisted that royal flushes were common because you saw one happen right away, and if you refused to consider the possibility that you just witnessed something rare, you'd lose a lot of money at poker. That's what we're doing with the origin of life. We saw it happen once on the only planet we've examined in detail, and we're announcing it must be easy. We haven't examined any other hands. We have a sample of one. And here's what really bothers me. People sometimes say, well, we found amino acids on meteorites, and we've detected organic molecules in interstellar gas clouds, so the building blocks of life are everywhere. True, the building blocks are everywhere. But having building blocks is not the same as having a building. I have a pile of bricks in my backyard. That doesn't mean I have a cathedral. The gap between amino acids floating around in space and a functioning self-replicating cell is not a small gap. It is a chasm so wide that no one has been able to bridge it in a laboratory despite decades of trying. We cannot, as of today, create life from scratch. We don't even fully understand how it happened the first time. All right. Suppose I'm wrong about that. Suppose life really does pop up easily on lots of planets. Give it to me. Let's say 1/4 of all habitable planets develop simple life. That's still an enormous number of living worlds. Billions and billions, as Carl would say. Now comes the second filter, and this one is vicious. Life existed on Earth for roughly 3.5 billion years before anything you'd call intelligent appeared. 3.5 billion years. Let that sink in. For the vast majority of Earth's biological history, the most sophisticated organism was a single cell. Then multicellular life appeared, and it took another billion years or so before anything had a brain worth mentioning. Then hundreds of millions more years before anything was building tools and asking questions about physics. So, here's the question. Was that progression inevitable? Was it guaranteed that once you have simple life, you'll eventually get complexity and intelligence? Or was it an accident? A series of freakishly unlikely events that just happened to chain together on this one particular planet. The evidence, I'm sorry to say, leans toward the accident theory. Look at what had to happen. He needed a very specific kind of cell, the eukaryotic cell, which appears to have arisen from an event that happened exactly once in the entire history of life on Earth. One bacterium swallowed another, and instead of digesting it, the two formed a partnership.